saying. So the laws of logarithm. Okay, now when we talk about the laws of logarithm, I said we have 5 laws. The first law is the addition law, the second one, subtraction law, the third law, the power law, and so on, and how the 5 law went on. Now the addition law, for example, we are having 2 logs, log to base a to power b, then minus log to base a to power c, then plus log, alright, sorry. Let me make it addition because the first one I said is addition rule. Now when you see a log value like this, in indices, there is a similar occurrence that happened in indices. But here in logarithm, when you see 2 logs like this, and you are about adding them, what you do, you take one log base, and multiply the power, b multiplied by c, or what? Log to base a to power what? B, c. You get? That is how we multiply, we add the log values. So there is almost an impossibility of adding 2 different logs that have got different bases. Okay? Yeah. Now number 2. Okay, let's take an example for this one. Example, let's say log to base a to power, log to base 2 to power 4. Let me use 3. Plus log to base 2 to power 5. Now what you do, take one of the log bases, and this is what? Log to base 2. Now we multiply the powers because here is addition. So 3 multiplied by 5, that is what? 15. So this equals what? Log to base 2 to power what? Power 15. And this gives the answer. Alright, that's how the addition states, okay? Then the subtraction rule. The subtraction rule of log. For example, we have the log to base a to power b minus log to base a to power c. Now what we do here, we're going to what? Take one log base like we did here and do what? And divide the power. So this is going to be what? Log to base a to power b divided by what? By c. Or I can have this as log to base a to power b all over what? All over c. Similar occurrence happens when we have log to base 4 to power 3, okay, to power 6, then minus log to base, yes, minus log to base 4 to power, let me use, okay, let me use 12 here. Alright, now when you see something like this, remember since the log bases are the same, we are taking one of the base, and then what? And then we divide the powers. It becomes what? 6 all upon 12. Or you write 6 divided by 12, it's the same thing. Now here we end up adding what? Log to base 4 to power what? 1 all over 2. So this is how we arrive. This is definitely our answer, okay? Alright. So this is our answer. Because we're not simplifying further, we just evaluated, alright? Now, that is for the law number 2. Then the law number 3 says, for example, we have log to base log to base a to power a. Whenever you are having log to base raised to the power of an equal number of that base, the answer is what? It's 1. Alright, the answer becomes what? Becomes 1. Then number 4 law says that, I'm going to give an example because there's even an invaluable example, alright? Now, for example, you are having log to base a to power c, alright? Or let me just say, log to base a to power b to power c. The third generation of power can be used to multiply this log afresh. In this form, that c will be multiplying log a to power what? Power b. Here is the example. We have a problem we've not completed here. So for example, like that, for a question like this, you are going to take this 5 to the back to multiply this, and this becomes what? 5 multiplied by what? Log to base 2 to power 2, and that is what? X. Now from log number 1, log number 3, we can say 2 to power, log to base 2 to power 2 is what? Is 1. Then this can be what? 5 multiplied by 1 gives us x, and then what? 5 times 1 is what? Is 5. So our x here is what? Is 5. Okay, so remember I said we are being guided by the rules, okay? To work with. We work with the rules that are being given to us. Alright, now these are some of the basic laws. Then the last law says, alright, the last law states, for example, we are having something like this. A log value raised to power of a to power b. Okay? And there is no similarity between them. That we are allowed to take our own log, your own stylish way of doing things, and we can get something like log to base, let me use a value I've done this before, to base k to power b all over log to base k to power what? Power a. Yes, this is what it says. So you can take your own stylish way and produce another base that might be common to be able to help you work with this and help you work with what? With this at the same time, and then work with that one, arrive at an answer. Alright, now let us go to problems we have on logarithm. So you should remember, you should always note that whenever you are when you are listening to a tutor class like this, then you are not expected that after paying attention to what they've said without putting into practice, you're not expected to be perfect. So when you want to be perfect, after you've understood, you can go back to your past questions and get more questions to what to deal with. Alright, now, alright, special cases. Now here, number 1, I have what? Log to base 2 to base 2 to power 4 plus log to base okay. Working by the rules, we already know this is log to base 2 to power 4 plus log to base 2 to power 8 minus log to base 5 to power 5. So what were the rules to get an answer here? Now by indices, what can I use to represent this one? A value that I'm going to add a similar base to what? A similar, yes, value to the base here. So that is what? I can get 4 as what? 2 to power 2. And I can get 8 as what? 2 to power 3. Because I'm going to add a similar value to my base. Alright? Now I can work with that one. Alright, now let's go. This is log to base 2 to power 2. Sorry, I'm using 2 to power 2 to represent 4. Because 2 to power 2 again. Then plus log to base 2. I'm using 2 to power 3 to represent 8. Becomes 2 to power 3. Then minus, then you already know that log 5 to power 5 from log number 3 is going to give us what? 1. So if I add this 1 there, I have no problem with it. Okay, now let us go on. Now, by log number 3, I can take this 2 to multiply this log. This becomes what? 2 log 2 to power 2 plus 3 log 2 to power 2 minus 1. So 2 to power 2 log 2 to power 2 gives us what? 1. So alongside here, and 2 times 1 is 2, and 3 times 1 is what? Is 3. Then this comes what? 2 plus 3, then what? Minus 1. 2 plus 3 is 5, and removing 1 is 4. So answer is 4. Yes, that is how we work on what? Logarithm. use your laws very well and deal with the question, arrive at a better answer. Alright. Now let us take a problem number 2. Problem number 2. Alright, now log to power 2 raised to power 27 all over 4. Then minus log to power 2 raised to power 9 all over 8. Then plus log to power 2 raised to power 1 over 24. There is a problem here. There is a problem here given for us to solve a logarithm. Alright. Once again, I say welcome to my YouTube channel. Alright. So please do to subscribe to this channel. So as we proceed on solving this question. Now, this is what. Remember, I can take one of all these bases, work in addition and work in subtraction at the same time. Yes. It is very possible. Then it becomes what? Log to base 2. Because they are all in base 2. Then what? I'm going to take this one, divide by this one, and multiply by this power. It is true. That is according to law number 1 and law number 2. Yes. Now it becomes what? 27 over 4. Then what? Divided by, because it's subtraction, divided by what? 9 all over 8. Then multiplied by 1 over 24. Yes, and it becomes what? Log to base 2 to power what? 27 over 4 multiplied by what? 8 over 9 multiplied by what? 1 over 24. Now I can cancel. So 9 can cancel this one to give me 3, and 4 can cancel this one to give me 2, and 2 can cancel this one to give me 12, and 3 can cancel this 12 to give me 4. So I'm left with what? 1 over 4. Now my log to base 2 is equal to what? 1 all over 4. I'm not done yet because I'm to evaluate it, I'm to simplify it, I'm breaking it down to the simplest. So by indices, I can write this 1 over 4 as what? Log to base 2 to power what? 4 to power what? Negative 1. And again, in indices, this 4 can be expressed as what? 2 to power 2. Alright. Now let me say this is what? Log to base 2 representing 4 by 2 to power 2. 2 to power 2, because I'm going to multiply the power by this negative 1 here. I'm not doing away with it, alright? And it becomes what? Log to base 2 to power 2 to power of what? Negative 2. The negative 2 can come here to multiply, and the answer becomes what? Negative 2 multiplied by 1. Yeah, because 2 to power. That is negative 2. There is no need for too much talking. You already seeing it, you already know the answer from the beginning. Yes. That gives us the spirit of what? Solving mathematical problems. Solving what? Mathematical problems. Then, now, if you are taking it down, please take down. Alright. So, question number next. I have log to base 5 to power of what? Power of 0.04. All upon log to base 3 to power what? To power of 18. Then minus log to base 3 to power what? To power 2. Now let us deal with this one. This one is a big guy. And we need to deal with these big guys with big stones. Alright? We need to deal with the big guys with big stones. Let's do it. This is 0.04, and I can express it as what? 4 over 100. Yes, 4 over 100. So this becomes what? Log to base 5 to power what? 4 all upon 100. All over what? Log to base 3 to power 18 minus log to base 3 to power 2. Look at this guy very well. This guy can make headway for us. Good. You can make headway for us. You can deal with him somehow. But that process, I'm seeing it as a long process anyway. We're going to handle it with our big stone. Okay? Like we can do it with our small stone. Now this can be equal to 4 divided by 5 it can be expressed as 1 over 25. Okay, so if you can do it laymanly or in a primary way, you can do it. Okay, you see that you're going to have what 1 over 20 what 25 all upon, I can take one base and what divide the powers, because what log to base 3 to power what 18 all over 2. Now this implies that I can rewrite this one as what 25 to power negative 1 like I did the previous question. Then this is going to be what log to base 5 to power what 25 to power what negative 1 all upon log to base what to base 3 to power what to power 9. Now I can express this guy as what 5 square, right? Then because what log to base 5 to power what 5 square multiplying what negative 1. 5 square multiply what negative 1 like I did in the previous question. All over what log to base 3 to power what that can be expressed as 3 to power 2. Here this becomes negative 2. I'm going to multiply log 5 to base 5 and that is 1, right? So this becomes what negative 2 multiply what log 5 to base 5 all upon 2 multiply what log to base 3 to power what to power 3. Now negative 2 multiplying this whole answer, this implies that we'll be having what negative 2 times 1 is negative 2 all over 2 multiplied by log 3 to power 3 is what is 2. Now divide this value, we are going to have negative 1 and that becomes our final answer. Yes, yes. Okay, now logarithm is a very funny topic in mathematics. So it goes broad, viral, covering almost all aspects of mathematics. So whenever the laws you have met in logarithm, they should stick to your mind. And when you see them involved in other topics in mathematics, you should be able to differentiate them and deal with them in their normal way. All right. Now, logarithm also involves calculation in the equation. So we can solve logarithm in simultaneous equation form. We can solve logarithm in a quadratic form. We can solve logarithm in a cubic form. Yes. Let me take this one off. Let's place a problem whereby we solve logarithm in equation. Logarithm as an equation. Okay, logarithm as an equation. Okay, here we are given a problem. We say that says 2 log to base x plus log y minus 2 equals to 0. And we are asked to find x in terms of y, meaning we are not going to have a real value as a true number as an answer. So we are going to find x in terms of y, meaning that x will be equal to log missing with y. Alright. So let us go on. That is what the instruction to the question now asks us to do. So this comes what to log to what x to power what power 2, right? And this is plus log y minus 2. Here, some people will be confused that there is no base given to us here. It's true. So when you see no base given to us here, we can take one thing as our base. Alright? That is why I like mathematics. It is very easy to alter. Yes, it's true. Very easy to alter. So here, it is not altering though. It is what? It is a way of life. It is the culture of mathematics. So we can take a base. So examiners or professors do take 10 as their base, okay, in most textbooks. So I can decide to take 2, but I can also decide to take 3. So let me follow the way of what the men ahead of me. Now let me say this is what log to base 10 to power what? Okay, it is log to base 10, and this one is log to base 10. I can still what? Then I can what? I can take the powers. Alright? I can take the powers. Yes. Okay, let's proceed. I can take the powers. Now, this is x squared. Multiply by what? Into what? Y minus 2 equals to what? Equals to 0. Let me know if that question is right. Okay, it's right. The question is correct. So it's going to be a big stone to tackle, a big guy to tackle. Alright, opening the brackets, we're going to be having what? Yes. Watch this. Watch this. There is possibility in doing something. Let me think if I can add possibility here. Now, if it is 0, I believe it will be possible. It will be possible that I have something like this. Yes? 0 multiplied by what? By log to base 10. It's power 10. Yes? Log to base power 10. So taking the 0 up here. Now I'm going to add what? Log to base 10 to the power of what? X squared into y minus 2. Right? So taking the 0 up here, I'm going to add what? Log to the base 10. To base 10 is equal to 0. Now, let us go on. In indices, when you have value like this, the answer is what? Is 1. A value to the power of 0 is what? Is 1. Okay, now let us see whether we can do that one like that. So it becomes what? Log to base 10. Sorry, I can track it off like this. Yes, because what? X squared into y minus 2. So you give me what? Give me 1. Yes, and this guy is going to cross to this side, and because what? X equals what? 1 over y minus what? Minus 2. Sorry, x squared. Now I can rewrite this value, and it becomes what? X equal to what? X squared, sorry, x squared equals what? Taking this guy up, y minus 2 raised to the power of what? Negative 1. Because it is this negative 1 that if I remove it, I'm going to take it back to this situation. Now, crossing the square here, it becomes what? Square root. I remember square root to the power what? 1 over 2. Alright? Now, multiplying this, it becomes what? Into y minus 2 raised to the power of negative 1 times what? 1 over 2. And my x is going to be what? Y minus 2 raised to the power of what? Negative 1 over 2. Yes. Yes, this is how to do it. So remember, they said express x in terms of, okay, express y in terms of x. What are we doing? Here I've just expressed x in terms of y, not the other way around. Okay, so if I were to express y in terms of x, so we should be looking for y, right? So x is going to cross and not y crossing, okay? Because what? Y minus 2 equals what? Come here to divide, come 1 all over what? X squared. Alright, now it becomes, I can take it up, it becomes y minus 2 equals what? X to the power of what? Negative 2. And taking 2 here equals what? Y equals what? X to the power of negative 2, then plus 2. That's life. That's how we do it. So, another problem for us. Yes. The more you go on solving logarithm, you might begin to face more problem on it. Alright, then let us go on. Now here they said if x to power blah 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 blah, you better write it down in the thoughts. If 2 to the power of 2x minus 3y equals what? 32. And log with this thing. Easy, I'm coming. Let me check the question from where I started. If it is actually correct, okay? Please pardon me. Let me check if it is actually correct. Okay, log y to power x. I was thinking it's log x to power y. Log y to power x equals what? Equals 2. Alright? Now let us go on. They said we should find x and y. You see where simultaneous equation comes into logarithm? Or I should say logarithm goes into simultaneous equation. Find x and what? And y. You are not expressing y in terms of anything. You are going to have x as a value and y as a what? As a value also. Can we proceed? Of course we can. Now let's take the first equation. So the first one says 2 to the power of what? 2x minus 3y equals what? 32. In indices we can write 32 as what? 2 to the power 5. Of course I can cancel this one out and it becomes what? 2x minus what? 3y equals what? Equals 5. I can call this one equation 1. Now this one, let us hit it. Let us hit it. So I want to play a magic here in the second equation. It is not a magic, but I told you it is the culture of mathematics. So I can say this is 2 multiply what? Multiply log y to power y. So 2, I see what I'm showing. 2 can cross it up. And then becomes what? Log y to power x. Then equals what? Equals what? Equals what? Log y to power y, then to power what? To power 2. Then this guy can cancel this guy. So s equals what? S equals what? Y squared. Did you get? So x equals y squared. Then, if x can give me y squared, look at the first equation. I can suffix the value of x into what? Into this equation 1. So substitute the value of x. So by substituting, putting everywhere I see x, I'm going to put y squared. So it becomes what? 2 into what? Y squared minus 3y equals what? Equals 5. Yes? Yes? So what's going to happen here? This is going to be what? 2y squared minus 3y, then carry y here becomes what? Minus 5. Oops! This guy is giving us what? A quadratic equation. I'm going to deal with it what? Quadratically. Yes. So, in quadratic equation, you use this, the value of a here to multiply the constant c, and that becomes 10. If I'm not writing it down, it becomes 10. Now, flip 2 numbers, and when I add them, it's going to give me minus 3. I'm multiplying them, it's going to give me 10. When I add them, it gives me minus 3. Multiply them, it gives me 10. 5 and 2 are going to try that too. 5 and 2 are going to do that task for us. Okay? But not exactly, okay? So 5 and 2, multiply them, they will give me 10. I'm supposed to give me what? Minus 10. Because 2 times minus 5 is minus 10. Alright? Now 5 and 2 are not going to give me minus 10. Are you getting this now? Then I said if I add them, they will give me 3. So the possibility of giving you a lesser negative number simply means that the bigger number in the equation is going to be carrying a negative sign. So minus 5 plus 2 is minus 3. Then minus 5 times 2 is what? Minus 10. I can suffix this into this place. I'm getting what? Let me take it to the top. Let me take it to the top. So remember, it's minus 5 and 2. So it becomes what? 2y squared then minus, I'm going to put this guy here, minus 5y, then plus 2y. So minus 5y, then what? Plus 2y, so I'm going to write 3y again, then minus 5. Minus 5 then equals what? Equals 0. I'm bracketing these ones out. So what is common here? Y is common here. That's what my dad told me how to do it. Then this becomes what? 2y left to right minus 5 into, so what is common here? Y is common. Then what? Yes, then 2y minus 5. These two are now the same. So I can take one and make another expression for you. Here becomes y plus 1 into what? 2y minus 5 equals what? Equals 0. I can be taking this out gradually. Alright? Now, I can equate them individually to what? To 0. Because y plus 1 equals to 0. Or 2y minus 5 equals to what? Equals 0. Now this becomes what? If 1 cross here, it becomes what? Negative 1. Or this becomes what? 2y minus, if this constant cross to this side becomes what? Positive 5. And when I divide both sides by 2, becomes what? 5 over 2. And that is what? Let me say 2.5. 5 divided 2. So y is either 2.5 or y is negative 1. So also we're going to be having two answers for what? For x value. Alright? Yes, I'm going to have two answers for x value. Remember that the value of x is equal to what? Y squared. Are you seeing this now? But the value of x equals y squared, like we solved in the first equation, right? Okay, sorry, in the second equation. So I can say, putting this value here, so x can be equal to square negative 1. The answer is what? 1. So x can either be 1 or, okay, now this is what? When I square 5 over 2. When I square 5 over 2, I'm going to be having what? 25 over what? Over 4. 25 over 4. And that is what? 6 whole number, 6 and quarter, okay? That is what? 6 and what? And quarter. That is when I square 2.5. It gives me what? 6 and what? And quarter. So that is to say, when y is equal to negative 1, x is going to be what? Positive 1. And when y is equal to